Okay. One of the design requirements for structural steel, we say, is safety. By the term safety, we mean the whole structure, including all components that form the particular structure, should fulfill all safety requirements as defined in prevailing codes of practice. They have to provide at the end sufficient safety for all users. Okay? The second requirement is performance. Now here, we say the structure must fulfill all serviceability requirements. This means that the structure should perform well in terms of deflections, vibrations, fatigue, among others. So all those should be within acceptable limits. So once you design, make sure you check your structure with respect to serviceability requirements. By so doing, we shall ensure that comfort to users are attained. Comfort to users are attained. Next is the economy. It is the expectation that the design of structural steel will lead to the structure that is economic and will fall within the budgets of the client. We don't expect that the design of structural steelwork will lead to discouraging the client from implementing the project. We expect the design will be economic and capable of being carried out within the client's budget. So we also expect that your structure, in terms of economy, will also have less difficulties in fabrication and erection. We expect that you will use available or readily available sections. That is the sections that are available in the market. So this means that when you make a design, before concluding, make sure you have sufficient information regarding availability of the materials or the sections that you are proposing for use. Then you have also to consider available and affordable means of transport from fabrication plants to the site. Yeah? And again, we also discourage site welding. Instead, all welding works has to be done in workshop. Influence of oxygen. Too much oxygen in welding reduces strength of weld joint. That's why we discourage on-site welding, where we have a very huge amount of oxygen. Instead, make sure you carry out your welding works in workshops, where you have limited oxygen. And by so doing, you'll ensure or you'll enhance strong weld joints. Are we together to that point?
Yes.
Okay. Another thing is elegance. This is the appearance, beauty. We expect the complete structure, together with its smallest details, they have to be attractive. They have to be impressive. They should not be awkward. Make sure you design the structure that attracts people. Okay? So these are 4 basic design requirements for any structural works which has to be fulfilled. Is there any question? Okay, if there is no question, then let's proceed. So now, as far as the British standard is concerned, the design of structural steel falls under the limited state design method. There are several design methods, but one of them, and that it is within our scope, is called limited state design method. Okay? Now, before implementing this design, it is very important to know these limited states. What are the limited states? How many limited states do we have? What are the consistencies within each part of the limited state? Okay. Now, recall, as we have discussed just now, that means we said the designer should ensure the design structures are fit for their purpose. This is what we talk about, the serviceability issues. Then we talked about safety. With respect to safety here, we are talking about strength. Okay? This one, it is about the serviceability, the functions. That means the structure should fulfill all required purposes and provide sufficient comfort to the users. However, we have to ensure that the structure is safe to users. How? This is about strength requirements. Then we have to consider the economy. We say your structure has to be within the budget. And then it is about beauty. So if we consider safety, we say there are some uncertainties which may affect the safety of the structure. This includes uncertainty about loading, uncertainties about material strength, and discrepancies of the structural dimensions. All this finally will affect the structural strength, which is the main function for the safety of a particular structural steel. Now, uncertainties in service, okay? Service, now we are considering services. This one, changing in load magnitudes. That is variability of the loads. Changing in magnitude of the loads. Then changing in load distributions and the positions throughout the structural elements. So all these will finally affect the serviceability of your structure. Okay? Now, after that introduction, now with respect to limit state design, we have two limit states or two major groups of limit states. One is called the ultimate limit state, and second is what we call serviceability limit state. I'll start with the first one, which is the ultimate limit state. So the ultimate limit state, if you really consider their components, one will find these limit states mainly talks about the structural strength. They talk about structural strength. So the first limit state is called limit state of collapse. The term collapse refers to rupture of a critical section or buckling of a load-bearing member. So you'll find this one, they have direct relationship to the structural strength. The second limit state is called limit state of local damage. Local damage. Typical example is an excessive buckling of the web member. Okay? The first one, this is the overall buckling of the whole section. But local damage involves, example, an excessive buckling of the web section, whether in an H or in I section. So that one is the local damage. Again, this one also have direct relationship with the strength of the structure. Third one is the limit state of fatigue. Limit state of fatigue. And the last one, this is the limit state of fire resistance. So in this case, we consider resistance to structural collapse due to fire, the resistance to penetration of flames, as well as the resistance of heat transmission. We know that when steel gets hot heat, it yields. And once it yields, then automatically it will, the structural strength of that particular steel is highly affected. Okay? A typical example of the heat effect is the structural failure or the structural collapse of the World Trade Center in the year 2001. I think we remember that scenario. You remember that disaster?
Yes.
Or were you not born? I think we remember it. So one of the causes of the structural failure of that huge structure was the heat transmission within the structural steel members. The structural system of the World Trade Center towers was mainly composed of structural steel columns and beams. So when they were bombarded, then flames were generated. And once flames were generated, they cause heat transmission to the steel elements. That heat causes steel or causes steel to yield. And after yield, they lose their strength. Subject to that, the whole buildings failed abruptly. Okay? So that is about the ultimate limit states. We said we have 4 limit states, which include limit state of collapse, limit state of local damage, limit state of fatigue, as well as the limit state of fire resistance. Okay? Question?
No.
Okay, thank you. Then we have the limit state of impact resistance. This one has to be considered whenever there is a probability of shocks. A typical example of shock is earthquake effect. Okay? However, in our scope, design due to earthquake loads is not considered. So although it is part of the limit state, but our concern will include the only 4 limit states. The 5th one will not be covered, right? Well, so let's look on the serviceability limit states. So the serviceability limit state, this one reflects functionability of the structure. And these limit states includes the following. 1, it is the limit state of deflection. Initially, we said that one of the requirements of the structural steel is to sustain deformations within acceptable ranges as stipulated in prevailing codes. So that is about serviceability. So say 1, the limit state of deflection. Any deflection should be within the acceptable range. It should not impair appearance or efficiency of the structure. We should not expect that the designs of steel will lead to some problems regarding openings, difficulties in openings, for example, or suitability of arranging various utilities within the structures. Second, the limit state of vibration. For structures that are subjected to vibrations, like machine foundations, for example, members supporting transformers and others which are subjected to vibrations should neither cause discomfort or damage to the structure itself, as well as all structures that has been constructed or will be constructed near that structure. So the vibrations of the structure should not cause any discomfort to the users, as well as to all other structures that are constructed nearby that particular structure. Next is limit state of durability. I think you remember in introduction where we said one of the key issues in structural steel is its susceptibility to corrosion. Corrosion weakens steel. And by so doing, it reduces the lifespan of the structure. Therefore, you have to ensure that special precautions or special treatment against corrosions are taken into account when you make a design of that particular structural steel. By so doing, you shall fulfill the requirement for durability. Okay? Question to that point? Is there any question? Okay. So if there is no questions, I think for today we can stop here. So we shall proceed tomorrow if God wishes, right?
Yes, sir.
Yes.
Okay. Thank you and enjoy your day, please.
Thank you. And same.